Alright, this is Mr. H here. Sorry I'm not able to make it. We're going to walk you through how to do the heat equation. So we're going to go into energy of matter, notes, intro heat equation, and then let's throw that thing in notability. Alright, so we've talked about heat can flow in to an object or out of an object, right, from high energy to low energy. But there's a way that we can actually measure it, and that's with the formula here, Q equals mc delta T. Q, if we look, is the energy that flows in or out of the object. And we're going to set that equal to the mass in grams times C, which is specific heat capacity, which we'll talk about shortly here. And of course, delta T is the change in temperature. Okay, so when you put energy into an object, its temperature will increase. So what we're going to place here is how much the temperature changes. Not just the absolute temperature, but how much it changes. So, Q is the energy that's being transferred. Okay, now, when energy flows into an object, it's gaining energy, right? The energy is increasing. So, if we are looking at a scenario where we are gaining energy, okay, our Q will be positive if the energy is gained by the substance. And if you lose energy, it's going to be negative. Okay, and that kind of relates to money as well, right? Like if you give somebody $5, right, their cash flow is positive 5, and your cash flow would be negative 5. Okay, again, as I stated before, M is the mass. That needs to be in grams. And then C is a specific heat capacity. This needs to be given to us. Okay, and specific heat capacity is the ability of a material to change its temperature when gaining or losing energy. Basically, this value here tells you if something is an insulator or a conductor. Okay, and then lastly, delta T, the change in temperature. If an object is gaining energy, right, then the delta T will be positive because the temperature will increase. And if our temperature goes down, then our delta T will be negative because it's decreasing. So let's see how this is going to work here with a practice problem. So a 15.75 gram piece of iron absorbs 1,086.75 joules of energy, and its temperature changes from 25 degrees to 175 degrees Celsius. Calculate the specific heat capacity of iron. So what I recommend you do is go through and label all the information you have. So we have that our iron is absorbing 1,086.75 joules. So that means it's increasing. So that's going to be a positive value, 1,086.75 joules. The mass is 15.75 grams. Again, it's right there in the problem. Okay. C is our unknown. Okay. So we're going to calculate the specific heat of the iron. So there's your unknown. It's going to be C. And then delta T is the change in temperature. So our temperature goes from 25 to 175. So my temperature goes up by 150 degrees. So now all we need to do is sub everything in and solve. So Q equals mc delta T. So positive 1,086.75 grams equals M, 15.75 grams times C, it's unknown, times delta T, which is positive 150 degrees Celsius. Now we just need to do some algebra. So what we'll do is we'll combine our terms. So we've got 15.75 times 150. So 15.75 times 150 is going to be 2,362.5 C times C. and that's equal to 1,000, positive 1,086.75, and that's joules. Now we just need to divide both sides by 2362.5, divided by 2362.5, falls out over here, and 1,086.75 divided by 2,362.5 is 0.46. 0.46, and the unit for specific heat is joules per gram degrees Celsius. And that's it. So all we're doing here is identifying the variables, plugging them into the equation, and then doing some algebra. So I'm going to go ahead and have you try a bunch of practice problems, go back, reference this video if you need to. It should be pretty helpful. Thanks.